Hello and welcome back to Sheaff Math. In today's lesson, we're going to learn how to convert between degrees and radians. So let's just do a little bit of review about what degrees and radians are. Now, we know that there are two ways that we measure circles. Well, angles in circles, okay? And first one is degrees, right? And a circle has 365 degrees, as we've learned since we were little, right? So like this circle was divided up into 360 tiny little thin slices of pizza, and that makes 360 degrees. And so, sorry I had to refer to pizza, but sometimes the visual does make a lot of sense. All right, and we know that half of a circle is half of 360, which is 180. A quarter of the circle is 90 degrees, and so on. Okay, and so it's really easy for us to understand degrees. But leave it to mathematicians. They had to get all fancy on us, and they had to pick another way to measure angles and the circle. And so actually this helps in higher mathematics a lot more, and so that's why we have to learn this. And so we have the circle again, but this one is very interesting. Okay, so we have the radius there, and I'm going to put another radius right here. Now I put this one very special. I made a very specific slice of the pie right there. And if you notice the arc part of the circle, which is between those two radius lines, that one is exactly the same length as the radius. Okay, so imagine that. We've got the radius, the two radii there, and that arc is the same exact length, but it's on the arc. And so this is called a radian, okay? Because it is like the perfect radius slice. All three sides are radius units long. Now, if we keep going around and seeing how many radians we actually have, so there's another radian, you'll have to excuse this, the graphics here. They're not the best, but we have, let's see, 5, 6, and then it looks like we have a little slice left. And that's exactly how many radians are in every circle. And let's talk about that for a little bit. So let's look at that circle again. And there's about 6, and then just some change, right? A little slice left. And so the reason for that is because you know that we're trying to figure out how many R's or how many radius lengths are around the circle. Well, we know that for each of those arcs, there's 6 whole ones, and then there's a little one left over. And so how many radius arcs are there? Well, there's 2 pi, right? Or 2 times 3.14, and so on. And how many actually is that? Well, it's 6.3. Well, it's rounded. It's about 6.28 something, but I rounded it to, it's just a little bit over 6 slices of radians there, okay? And this is on every single circle. And so when we are measuring using radians, we'll measure it using these specific, special measurements, okay? Now, how do we convert degrees to radians? Now, first of all, we know that 360 degrees equals 2 pi radians, right? Or about 6.3 radians. Now, if we put this as a ratio, kind of like miles per hour, right? 360 degrees per 2 pi radians, we can actually use this to form a proportion and find out any amount of radians for the degrees. So if you know the degrees, you put it in there and you can solve for the x radians. So 360 over 2 pi equals, let's say we had 45 degrees in our question, and we're trying to find this. And so we cross multiply. We get 360x equals 90 pi. We solve for x, so we divide 360, And we end up getting 90 pi over 360, which can simplify. That 90 and 360 simplifies to 1/4. So pi over 4 is the amount of radians in 45 degrees. Okay? All right. So let's try a shortcut, because that was quite a bit. If you had to do that proportion every time, it might take you a while. And so this is really easy. So we know 2 pi, right, radians per 360 degrees. And so we can simplify that. 2 and 360 simplify to 1 over 180. So pi over 180 is our magic formula. All we have to do is simply multiply your degrees by pi over 180. That's it, right there. Whatever x is, whatever your degrees are, put it right in there. So let's try some practice. Convert 90 degrees to radians. So, just like we talked about, 90 times pi over 180. Well, we get 90 pi over 180. That simplifies to, well, 1/2, which is pi over 2. And that is how many radians equal 90 degrees. What about 120 degrees? We simply multiply it by pi over 180. We get 120 pi over 180. That simplifies to 2/3. So 2 pi over 3. This is pretty easy. All right, let's just throw some random degrees out there, and we'll even do negative degrees. What do? We multiply it by pi over 180. And we simplify it if we can, and this one does simplify to negative 13 pi over 45. And there it is. That's it. All right, now, what about converting radians back to degrees? Okay, well, suppose you had to take pi over 2 radians and convert it back to degrees. Well, instead of multiplying it by pi over 180, you simply reverse it and flip it, and you multiply that pi over 2 by 180 over pi. Okay, now I know you can do some canceling, but I just want to show you we have 180 pi over 2 pi. We do some simplifying, and what do we get? 90 over 1, which is 90 degrees. Just like we saw earlier, 90 degrees is pi over 2. Actually, 45 degrees was pi over 4. All right, and there it is. So again, the same thing, except you just flip that 180 and pi, okay? All right, now what you've all been waiting for, the secret formula table. Now, get your cameras out, take a picture of this. These are the real common radians and the common degrees that get used in a lot of math. And so it helps if you just remember how many radians per degrees. If you have to find a very specific degree, that's different. But you can see that these are the big ones. Those are the ones that occur the most. And if you just take a look at it, look at that the bottom right. Well, let's talk about this first. So we got degrees, and then we have radians, the exact. And so when you have it as pi over 6 or pi over 4, that's the only way we can write it exactly. Anytime we plug that into a calculator, we have to round it, and so we get an estimate. And that's what the third column is, the approximate radians. And so you can see what those actually look like in real numbers. So a whole 360-degree circle is a little bit over 6 radians. The half circle, the 180, is a little bit over 3.14. What does that remind me of? All right, and then you can see how many they actually are, how many of those special radian pieces they are. All right. So there it was. You just learned how to convert between degrees and radians. They're not that hard. You just have to kind of remember a couple formulas, and hopefully you understood how it all kind of worked. So thank you for watching, and we'll see you next time.